Hey there, viewer-type folks, and welcome to the Daily Space Weather, and welcome to the Smash News Network, least busted name in news. We've got some spectacular imagery, as always, as we give you basically a guided tour of the sun and all the stats associated with it, Earth weather and space weather. So thanks for tuning in. Congratulations on realizing that the channel exists. This is the GOES-R 194 plus 304 angstroms 24-hour video. And that is a lot of sunspots and also filaments, which is what we'll start things out talking about. Yeah, huge solar filaments, materials suspended by magnetic fields around the sun's corona, defying gravity and causing things like these coronal mass ejections to happen. So here you can see this CME happening actually as we stream the video. A great example of material both ejecting and also collapsing. Here you'll see a little bit of both of that happening right at the end of this video, right there. Some material going down because of gravity, some material coming up because of magnetic fields. Again, lots of sunspots. We've got three areas of activity, both the west central and southwestern limb, the southeastern limb, and the northeastern limb, all showing flare-producing regions, magnetically complex sunspots. How about a close-up of the northeast? And check out this huge filament that's coming up over the northeastern horizon there. Huge filament there, and what I mean is this dark absorption feature right in here. Gigantic plasma filament. And let's take a look at sunspots. This is the data from yesterday plus today, SDO. And sunspot number is reaching up to 160 now. So this sunspot has grown quite a bit since yesterday. This one has degraded a little bit. These are mostly stable, and these have degraded a bit. Here's a colorized magnetogram. That's the same time frame, yesterday plus today. And let's take a brief moment to take a look at what's going on Croissant Earth. Before we do that, let's promote the channel. So take a moment to take in this brief commercial message. Yes. So, first of all, we've got merch. Today's featured merch product is Do the Math, featuring lovely graphics of the core of the Milky Way galaxy, known as Sagittarius A star, the massive radio source around which massive blue supergiant stars orbit at crazy relativistic speeds similar to the solar wind. That's hundreds of kilometers per second. Giant stars are orbiting the massive radio source at the core of our galaxy. Believed to be a supermassive black hole, it's known as Sagittarius A star. And if you're wondering if it's dangerous, the answer is no. You're like 26,000 light years away from it. Its jets are not oriented toward you. And really, our solar system isn't interacting with it directly at all. Except you could make the argument through gravity, because the sun does indeed orbit the galactic core. It just doesn't really interact with the galactic core. The galactic core interacts with the local environment and the rest of the galaxy via the spiral arms. So do the math when it comes to cosmology, and check out our merch. That's one of our most recent designs. Links below the video, as well as on the homepage. If you want to support the channel via subscription services, then consider becoming a member of the Smash Team at smashomash.com/Smash Team. You can find our links there, like our Hemp Lucid link, which we'll talk about here in a moment. Huge sale going on there. smashomash.com/Smash Team. We provide additional content. We even sent out a video today featuring additional content for bronze level. We do send out email notifications also when we put up videos, because a lot of people have complained about certain big tech organizations not notifying them when we put out content. smashomash.com/Smash Team. The best value is the gold annual paid up subscription. It's almost like getting 4 months of a gold membership for free, as it includes complimentary merch. Also, a huge sale going on at the Hemp Lucid shop, as I mentioned briefly. So click the links on the homepage or below the video to our Hemp Lucid link. You'll find our shop there. And don't forget to enter the promo code SMASHOMASH to save some dough on checkout. There are the most popular products, the CBD tinctures. And please visit our homepage if you're unable or unwilling to open your cobweb-encrusted wallet. Drop us a few clicks. If you want to send us an instant message, hit us up on Discord. There's a permanent invite link to our Discord chat right there. It looks just like this. You can also find us on Facebook and all over alt tech sites, as well, as if they're going to be some sort of a cure for the monopoly that exists for information itself on the internet. Links on the homepage for the Smash Team page as well, smashomash.com. And welcome to the Neo-Renaissance. And let's talk about volcanoes. Not surprisingly, Shivaluch is still erupting. In an explosive fashion, it's producing a 36,000-foot plume of volcanic ash. Please do not pole vault the caldera. Semeru also exploding, flight level 140. It's a 14,000-foot ash plume over East Java, Indonesia. Popocatépetl exploding, flight level 220 over central Mexico. Fuego exploding in Guatemala, flight level 140. Flight level 210 over Ecuador from Sangay. Flight level 160 over Ecuador from Revenador. 16,000-foot ash plume. And not sure about Peru's Sabancaya, the Peruvian volcano we're unable to detect. Don't assume that it's not erupting. Next, seismicity. And the past 24 have been a lot more calm than the previous 24. Let's check out the list, citing quakes over a 5 magnitude. So Papua New Guinea had a 5.4. That was yesterday at 14:10 Universal Time. Papua New Guinea also had a 5.3. That was at 18:09 Universal Time. So only 2 quakes of a 5+ magnitude in the past 24 hours. That's pretty seismically calm, especially considering how seismically active the previous day was. Let's get back to space. There is 171 angstroms, as well as 284 angstroms from the GOES-R. We did have some M-class flare intensifications, which we will get to here momentarily. First, some stats. The 10.7 centimeter radio flux now up to 171 solar flux units. Yeah, 171. So there's the 1-year chart to put that in context. The black line right here is the radio flux. 171 solar flux units is the new radio flux number. Sunspot number expected to rise at least to 160 the next time this updates later today. Space Weather Enthusiast dashboard still forecasting a little geomagnetic unrest late tonight, just before midnight time, Universal Time. I'm not sure if that's a coronal mass ejection that we forecast, but we are expecting a CME impact, a minor one, coming in later today. So sometime soon after this video, up until around midnight local time, we're expecting a CME impact. It could last as long as until about to this point tomorrow. So late today and early in the day tomorrow, we could see a minor CME impact. We'll see what happens. No one not forecasting that. It was pretty stealthy. So in their defense, no harm, no foul. At least so far, it's not expected to be a major impact anyway, like a KP 5.66 maybe. And let's take a look at Earth's magnetic moment from space for the past 4 hours. Here's Crescent Earth. As Earth's magnetic moment from space is crescent-shaped from the perspective of a solar proton from the meridional plane view, which you can see on the right there, looks a little bit like a crescent shape, doesn't it? Yeah, it's because all the funniest jokes are the ones that are real. That's the past 4 hours, pretty calm here geomagnetically speaking. Here's the past 4 hours of Earth's magnetic moment from the ground. Crescent Earth projected onto a fake NASA Adobe Photoshop spherical flattened plane distorted thing. Anyway, Greenland is not larger than North America, if you're wondering. So yeah, there's the past 4 hours of Earth's magnetic moment from the ground, showing the most likely places to see things like the aurorae. Again, things are geomagnetically calm at the moment. KP 2.66 is the current planetary K index. KP 2.6666667 is the current KP index. Next, we'll look at the real-time solar wind, which is measured outside Earth's magnetosphere out here at Lagrangian point 1. We did have a little regime change there. That could have been a CME impact right there. We saw a change in the plasma temperature. We saw a change in the solar wind speed and density, and also a change in the magnetic field all at once. So that looks like a minor CME impact. It was quite minor. Current conditions are 350 kilometers per second for the solar wind speed, 6.4 protons per cubic centimeter for the solar wind density. Besides that, things have been fairly unremarkable. There are your GOES magnetometers. Those magnetometers are located in a geosynchronous orbit at about 23,500 miles of altitude. Their orbits are located near the equator. The N's and M's, if you're wondering what those mean up here, these N's and M's, those stand for noon and midnight local time for the satellites. And let's take a look at the heliospheric current sheet, as there is a sector boundary crossing likely to happen before tomorrow's video. So there's a South Pole current sheet headed this way. If you look at the latest image, it's almost at stereo A. So we are expecting a South Pole current sheet to be at Earth by tomorrow's daily space weather video, as Earth is about to leave a North Pole current sheet at some point today, most likely. Keep in mind the magnetic environment can suddenly change, thereby voiding my forecast. Here's our line of sight field plot. That was the top view ecliptic plane. Here's our line of sight field plot. You can see that sector boundary crossing right here. Let's bring up the latest image. There it is. There's that sector boundary crossing. And we'll likely be in a South Pole current sheet by tomorrow. So we're going to look at coronal holes next. Here's our coronal hole line of sight field plot. And we've got some South Pole oriented coronal holes here now showing up around the equator, so those are more likely to be geo-effective. And let's bring up the latest image. So South Pole coronal holes here over around the eastern limb. Here's 211 angstroms. So these are South Pole. Right here is South Pole. And up here we have more South Pole oriented coronal holes. They'll get a little bit more well-defined in the coming couple of days, as there's a bunch of material suspended in the corona there obscuring them. They will appear to open up and get darker, especially in the 211 angstroms SDO wavelength. And let's move to sunspots. So there are lots. And according to the flare monitor here, the most likely ones to see major flares would be 3281, which is this one right here, and 3282, which is this one right here. Also keep in mind that these groups over here are very capable of producing large flares. So I would say actually the most likely place to see an X-class flare would be over here on the western limb, as these are becoming less and less likely to produce large flares as they're getting closer to the Earth-facing portion of the solar disk. Oh, and by the way, if you're wondering about the anisotropy of solar flares, the reason why they appear to be larger, we see larger flares at the limb of the sun than in the center disk. We put up a post yesterday on our Smash Team site, so smashomash.com/Smash Team. It was only for paying subscribers, so it's for gold and silver Smash Team members only. If you want to read about that, it'll cost you $2.99 for a 1-month silver membership at smashomash.com/Smash Team. But there is valid physics to explain why it is that we see larger flares at the limb. And it's not because of some idiotic nonsense like human consciousness, or because stars are magic, or because the sun decides not to, it doesn't want to harm technology by producing large flares in the in the center of the Earth-facing solar disk. That's not the reasoning at all. And by the way, that's not science unless it can be tested. Let's take a look at sunspots, and I must have forgotten to put something up. Bear with me a minute here. We've got a great SDO image of sunspots for you. So there's the past 24 hours. I'll let that play through one more time before we get to energetic particles and solar flares. And thanks for leaving comments. We'll address those comments momentarily. The ghost proton flux here, no spikes in the proton flux, no relativistic particles, and no major flares, although there were 2 M-class intensifications since yesterday's video. So 2 M-class flares were the largest solar flares of the past 24 hours. Again, a CME propagating as we make the video, so there's a radio burst that's actually happening right now. It's probably not over yet, so you probably didn't get an alert about it yet. And let's take a look at solar flares from the SDO's perspective, 131 angstroms. So that's all of yesterday plus today's data. Some great imagery for you there. And let's take a look at the flaring from the GOES-R's perspective. So here we've got the GOES-R. This is 94 plus 131 angstroms. And we'll show some close-ups here. So there's your southwestern limb. And those spots are getting more and more likely to produce major flares. So we're going to keep an eye on that. And when I say eye on, well, pardon the pun. Here's a close-up. Don't be surprised to see an M or even an X-class flare, especially from this near equatorial group, this group up here. Here is our southeastern limb. Lots of activity down there, and 3281 is very likely to produce large flares. Although, again, getting less likely to produce flares as it moves closer to the center of the Earth-facing solar disk. Here's a close-up. And here's your northeastern limb. And I think there is another sunspot slowly rising there behind the northeast. It may have degraded or evaporated entirely. It looks less active back there than it did just yesterday. But there's got to be some suspense. Otherwise, why would you tune into the channel tomorrow? What's that? You like facts about space weather and Earth weather? I know, those are great, right? Facts without the propaganda. It's what we're all about here at the Smash News Network. Least busted name in news. And what is going on with this? Thanks for leaving comments, John and Mike. And John wants to be sanctioned for repeatedly putting links in our live chats that have nothing to do with our content. So here's what's going on overhead Lehigh Valley. I just clicked now. This is skyandtelescope.org's star chart. If you're up before dawn, you might see Jupiter rising right ahead of the sun there, although I doubt it. It's probably too bright. And if you're checking out the sky after dusk, you might see Mercury there. Also, Saturn and the moon visible over Lehigh Valley, Pennsylvania. The moon is in Capricorn, which, again, I guess means something to somebody. Here's your solar system forecast. This is where things are located now. Here's your 1 week forecast for heavenly bodies as Mercury move around to this side of the sun, making it a little bit less lonely, as there are no gas giants on this side of the solar system, which is probably something that's got somebody forecasting doom for some reason without any sort of valid physics explanation. There's where things will be in a week. On this 22nd, we will have a crescent waxing moon by that point. And let's take a look at things like coronal mass ejections. So here is yesterday's coronagraph gallery, 95 frames. And we saw CMEs out of the southeastern limb and the southern limb. So here are today's frames. And if you're wondering if those are earthly directed coronal mass ejections, we don't think so, but we're going to take a look at stereo A as well, just in case. Because when you attempt to quantify things, you might actually have an understanding of what's going on with them. In other words, if you don't look, you're not going to see anything. Okay, so again, CME's out of the northeastern and southern portion of the sun. I don't see an indication those are earthly directed. Let's get a little closer than that. There's Jupiter sliding across the C3, located in your screen lower right. Again, those do not appear to be Earth-directed coronal mass ejections. And let's move to filaments. So a huge number of filaments, as we mentioned at the beginning of the video, huge number of huge filaments. So this is the one that's ejecting right now. Some of that might remain intact, but you can see, whoops, there it goes. It looks like only the southwestern portion of it remained anchored in the corona. The rest of it is either collapsed or on its way out into the greater solar system. We named this filament down here. We named that Bob Lehman yesterday. If you don't know who that is, well, you probably should join us on Twitter and follow the hashtag #NameThatFilament. So, I mean, this filament up here is the one that I would recommend naming today, or maybe this one. I don't know. There's a huge number of filaments there. Look at all those dark features and all those prominences. Those are all solar filaments, and those are the things that tend to go blasting off into space when we see a coronal mass ejection. Follow us on Twitter if you want to name filaments after living people. Name that filament. And there's the image that we're using. Thanks to our new followers over on Twitter and everybody who has tolerated the pathetic censorship, the disgusting, despicable censorship all across social media by certain utterly corrupt and morally bankrupt organizations. Here's the past 24 hours at SUVI 195. The GOES are at 195 angstroms. One of our new favorite wavelengths, by the way. Just spectacular. And let's take a look at that CME that's propagating as we film the video. So we're streaming it live, and there you have it. That's the past about 2.5 hours from the GOES SUVI. Not sure how much larger we can get than that. 100% zoom is sufficient. So just a great view of that there. And let's show the full disc. And for your new viewers out there, the GOES 16 SUVI has a wider field of view than the SDO, so it doesn't show as much detail. It's got lower resolution, but it also has a wider field of view, so you can actually see coronal mass ejections propagating, especially in the 304 angstroms wavelength. Moving on to bonus features, let's check satellite charging hazards first. We've got some minor surface charging hazards there moving into the central Pacific Ocean, currently in the eastern Pacific. That's low-energy electrons on the outside of spacecraft. GOES electron flux here showing up still kind of low, maybe a little bit lower than anticipated. Let's see what NOAA's forecasting. And even lower electron flux going into tomorrow. I would tend to agree, especially if we have a coronal mass ejection impact. If we don't have a CME impact, I'm expecting higher levels of electron flux. We'll have to see what happens. There's the one-year chart to put all that in context. Again, at quite low levels here of electron flux. That is measured at the F layer of the ionosphere. Feel free to pause the video on this frame if you're not familiar with atmospheric layers, such as the troposphere, where all your weather occurs, and where geoengineering doesn't occur. Here is the F layer of the ionosphere. We'll also show the anomalygram. There is the raw vibrational frequency. The F layer is the bridge between Earth and space in many ways. It's located at about 300 kilometers of altitude. The thermosphere, it's colder at the bottom and hotter at the top. And it's very diffuse. It is basically space. For all of you mouth breathing, for all of you air breathing, hopefully nose breathers. All right, so let's bring up the latest image here. Let's show the anomalygram first. There's the anomalygram. That's anomaly in megahertz from the 30-day median. South Atlantic anomaly looking like it's rather solidly in place over the South American continent. It's located right about here, in case you're wondering. You can see those huge gradations there in the anomaly. And here's the latest image, 12 o'clock Universal Time ionogram and 12 o'clock Universal Time anomalygram will also show the total electron content forecast. It's the free electrons up to about 12,500 miles of altitude. Feel free to pause the video on this frame. It's the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. Your GPS signal must travel through the inner portion of the outer Van Allen belt, the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere. Those free electrons cause signal refraction, which is what is being depicted in this imagery. These will be the most likely places to see GPS errors. And there is a little bit of a wobble going on there, as we typically do see with low levels of electron flux, historically noted by the channel. We also normally show that North American total electron content, but at the moment, it's not really working. So let's move on to the latest SDO intensitygram and latest SDO magnetogram. Do we have a new sunspot group rising up here? Not yet. There's a magnetically complex sunspot group. It's looking kind of symmetrical, though, so that's not typically a formula for large flares. Oh, check it out. There's a new sunspot group way up there. DAG, and that is a beta-gamma class sunspot group. Check it out. You've got a leading North Pole umbra and a trailing South Pole umbra. It is beta-gamma class. Case closed on that one. So at least one new name sunspot showing up today. Let's move to meteorology. And what we're looking at here is the CAPE index. Yes, the CAPE index. So, this is the convective available potential energy. And as you may see, there is a lot of it in the Gulf, and there's some severe weather in the forecast. So that's a lot of convective energy there, as there is a lot of warm water there in the Gulf. I mean, let's take a look at it. There you go. Some anomalously warm water in the Gulf, in fact, as that area right there is 4.7 degrees Fahrenheit above normal. And of course, warm water aids in convection. So the upwelling forces that are created as a result of that are in contrast to the cold air moving down from the north. Those downwelling forces, as that warmer, moister air is unable to support that dry, massive air coming from the north, is what causes things like tornadoes. Also, we see La Nina ending here. We see warm water around the equatorial Pacific Ocean. Another indication that El Nino is likely to come back. And I guess that'll cause people to move the goalposts when they flap their lips about climate. And I'm not going to really get into it beyond that. Although, if you don't understand physics, you should not be forecasting the climate or the weather or doing space weather. Continuing on to what we normally look at, the surface winds of the eastern world. There you have it. Jet streams of the east are looking like this. There's a divergence of the jet stream over China, okay? Here are the jet streams of the Western world. Doubled up jet stream over North America with some huge meridional bends there. Also some big bends in the southern hemisphere. And a transequatorial jet stream just off the west coast of South America. Here are the surface winds of the west. Low pressure here south of Alaska, as well as in between the Azores and Greenland. That's a huge North Atlantic low, as it remains stormy in the North Atlantic. There are the surface winds of the central world, Europe, Africa, and the Middle East, and there are the jet streams. We'll show you some forecasts here in a minute. First, the clouds and fog scenario over the Americas. That's the shortwave radiation map. It shows clouds and fog even when it's dark. And let's take a look at the weather.gov map for the U.S. So flooding continues in the northern central U.S. as a result of extreme snowmelt, as we've seen a 7th consecutive winter of record snow in the northern hemisphere. Flood watches there around Louisiana. If your location is lit up, click your location on weather.gov, the National Weather Service map, weather.gov. And here comes a forecast. This is the GFS 72-hour pressure and precipitation forecast. Again, strong storms coming to the Gulf. Although they have been weakened a little bit in the forecast since yesterday, so that's good news for the Gulf Coast. Not as harsh looking as they did, although a bunch of wet snow coming to the northwest, and an ice storm coming to the western Great Lakes region. A heavy ice storm. Let's look at total accumulated precipitation on the same model, the GFS 72-hour. And since a lot of that precipitation is going to be snow, we'll also show the snow forecast. Here's a 72-hour accumulated positive snow depth change in inches. Wisconsin is going to be almost completely blanketed. Also most of Minnesota, a large portion of Michigan. And some scattered snow in the northwestern U.S. Let's take a brief look at snow depth. So there's the current situation for snow depth. Still plenty of snow to melt, especially in the northern Rockies. Also, eastern California. Look at all the snow in Washington. Dag! That is a lot of snow indeed. As we reach mid-April today, and it's still not all melted. Long way to go. Expect meltwater floods to continue. Massive lightning storm here over the central U.S. in the past 10 hours. Strong one over Texas as well. I think that's mostly subsided. Let's check it out. If we see check it out where I learned to speak the English language. We see if we have any terrestrial strikes, and it looks like Houston. Well, the area east of Houston, at least. North of Lake Charles there. Quite an active cell there around Beaumont. Quite active cells indeed. To the north and east of Houston. That's our real... Dag! Look at the lightning! That was an absolutely insane lightning strike. That was like 24 lightning strikes all at once. Those are some severe storms, folks. So heed your weather warnings. Try lightningmaps.org. Next time you hear thunder, it could save your you-know-what. What else do we have? We got some active cells here in Arkansas and in Missouri. Bunch of lightning around the Lake of the Ozarks. All right, let's close this thing out with our real-time U.S. Doppler radar map. That's radar.weather.gov, by the way, if you're wondering. We'll focus on the lower 48. Here is clouds and fog from the NASA Interactive Weather Satellite Suite. And here is your water vapor map. Hopefully that helps clear things up. Here's your recap. And hopefully you're not consuming real crap on YouTube. The water vapor shall be the most definitive map in most cases. And you can see that dry mass of air there in Texas providing a bit of an impulse, pushing that moisture toward the northeast. Anyway, thanks for tuning into the Smash News Network, least busted name in news. Congratulations on realizing the channel exists. May that solar wind be at your back. And don't forget to visit the links over here and in these type of places. See you soon.